and that is our solenoid. Solenoid is just a bunch of loops stacked up on top of each other. Okay. And when I start to drive current through this thing, we know that there is a B field that is produced. But that changing B field says, I don't like that. I don't like that change in flux through the solenoid itself, and it's going to fight back against you. Okay. This thing is an inductor. Okay, we call it a solenoid, but it's also known as an inductor. And it fights against changing current. Okay. It doesn't like it when you change current. So let me give you an example of this sort of thing in action. And this is something that you can all try at home. Okay? And I want you to do the following. I want you to turn on your toaster. Okay? And let it run for a little bit. Turn off all the lights in your house. And I want you to unplug it from the wall. If you do that, what do you observe? Has anybody done this experiment? You might have done this by accident, right? Toaster's running. Instead of turning it off, you walk over to the wall and you unplug it from the wall. What do you see? You see a spark. Okay, it will spark. Why is that? Well, let's think about the toaster. Okay, here's our toaster. And there's some wires that are coming into the toaster. And then it goes to a wall plug, which has two big metal prongs on it. But inside the toaster, what is there? There's a bunch of heating elements. And those heating elements look like a big coil. So when you run current through this thing, the toaster looks just like an inductor. Okay, and now when you unplug it from the wall, here's the wall socket. When you unplug it from the wall, you in fact see a spark. There is a little tiny lightning bolt that goes from the wall to your toaster, to that plug. So don't do this at home if you have a gas leak in your house. That would be bad, okay? But if you have a normal house, plug in your toaster for a while, turn off all the lights, and unplug it from the wall real quick, and you should be able to see a spark. So now the question is, why? Why does this happen? Yes?
There's a change in flux, basically, for the coil to be electromagnetic field from the current.
Mm-hmm.
Then it goes into the wire from the wall, and then since this is an inductor, the inductor produces a current back.
Okay. So I don't know if you guys heard him at home, but that was basically the perfect answer. What he said was there is current running from the wall through the toaster. And now there is an electromagnetic field, there's a magnetic field specifically, that develops in this inductor, in those coils in the toaster itself. Okay? And everybody's happy, there's a big, strong magnetic field, but then you unplug it from the wall. And suddenly, that magnetic field drops to 0, but the coil doesn't like that. right? The coil wants to keep it going. And so the coil pushes current through the wires to try and do that, to try and keep that magnetic field going. Inductors fight against changing current. When you unplug it from the wall, you suddenly change the current. And so the inductor is going to fight to keep it going in the same direction. And in fact, so much current is generated that there is a spark between the plug and the wall. The electrons are trying so hard to keep that current going that they jump across that little gap. Okay, and the gap's going to be small. It's going to be like 1 millimeter or 2 millimeters. But you will be able to see a little tiny spark in that region, which is kind of cool.